At the edge of an international border, at the edge of the Pacific, at the edge of innovation, community, education, and discovery, you're listening to At the Edge of It All, a University of San Diego podcast where USD experts speak on topics and stories that impact you and the broader community.
Hi, I'm Cameron Zek.
And I'm Lisette Martinez, and joining us on the podcast today is Kate Boersma, Associate Professor of Biology at the College of Arts and Sciences here at the University of San Diego. Thank you for being with us.
Thank you so much for having me. This is really nice.
I'm very excited to talk to you today, and as we do with a lot of our guests, I want to start at the very beginning. Tell us where you grew up.
Well, I grew up on just south of Chicago. And I really grew up on pavement, which is funny. We'll get into what I do. Right. It is not on pavement. But I really wasn't an outdoorsy kid. But I did, when I was in grade school, I read this book, 50 Ways Kids Can Change the World or Change the Earth or something like that. Great book for a fourth grader. And it got me engaged in thinking about my role, thinking about how change can happen, and being aware of environmental issues that we were facing.
So let me ask you, what was it about that book that you remember just catching your attention so much so that it became your career?
Well, it was tangible. It was real to me. The things the book was talking about were things that, 50 ways that kids can save the earth or change the world, right? It really empowered me. And that made it accessible, made change accessible to me. It brought concerns. It was, kind of depressing for a fourth grader to think about all these issues we're dealing with as a society, but it was empowering in that I could do something.
And then you went on to school, and how did you decide that biology was the way?
Well, I started this Earth Club in middle school.
Oh, wow.
And then I started an environmental club in high school because nobody was doing this stuff. And I was like, well, I want to hang out with people who are into this. And so I just fell into it. And so we started a recycling program and accessible things that were in the 50 Ways to Save the World book. And then I went to college and decided I should study environmental science. That just made sense to me. I went to Northwestern University on the north side of Chicago, and they didn't have an ecology program. I'm an ecologist, and I had not taken an ecology class. The first ecology class that I took was when I was teaching. So I didn't have a history in that discipline. I studied environmental science, which was a lot of applied stuff, water quality, and here's how we can make cities more efficient. And then I knew it wasn't my cup of tea, but I did study abroad. And I'm always encouraging students to do study abroad because the very first time I took an ecology class was in Heredia, Costa Rica.
Oh, isn't that interesting?
In forest ecology. Right. And I fell in love with it. And we went outside and we saw the rainforest. And I was like, well, this is great. This is what I want to do. And then I went back for my last term at Northwestern. I hadn't taken any classes in any of this and decided I kind of wanted to pivot. So I graduated early and I took some time off. I took a Greyhound bus to Colorado. I was a ski bum for a little while. I worked as a liftie. I went to Portland, Oregon. I was a barista. And I finally, I just needed to find myself and figure out, I had this degree. I knew it was useful. I just needed to center myself and figure out what I wanted to do. So I got a job working at the Oregon Museum of Science and Industry, teaching outdoor science education. And that was intertidal. We worked in the San Juan Islands in Washington. And I didn't have a car at the time. I was carless. And so it was a great way for me to see the West Coast and experience, all these ecosystems I'd never seen before. And so then I fell in love with ecology by doing it and teaching it. And so when I applied for my master's program, I knew that was what I wanted to do.
Isn't that interesting how you said you grew up in Chicago, not necessarily so outdoorsy, but that's what became your life later. What were the lessons that you learned throughout those important years of your life? What was it that changed so much in you that you followed a different path than you kind of grew up around?
Honestly, I fell in love with it. This is why I'm always encouraging people to get outside. And I teach courses. Most of our biology students are pre-health, right? We don't have a lot of students who are going to go on to be ecologists or field biologists. We have a few, but I think it's really important for all of those students to get outside and experience these things that I've experienced, because you develop that care, you develop a connection with nature, and then that's what propelled the rest of my career. And that's what I want to impart onto my students here, is that same passion.
That's super cool.
Mm-hmm. And your main focus of your research is studying invertebrate communities in aquatic habitats and in rivers and streams that end up drying up. That's like a very, very narrow focus. How did you get interested in that specific area?
I kind of fell backwards into my research topic. I never liked bugs when I was a kid. I'd never been to the desert before. But an opportunity fell in my lap. I went to a talk that a friend of mine gave, a presentation when I was during my master's program. And she studied these streams in southern Arizona and northern Mexico, and they like dried for parts of the year. And then the water would come back and they would fill with animals again. And somehow the animals would disappear when it dried, and then it would rain, and then they would come back from wherever they were. And it just seems so magical to me. And that kind of like resilience, their capacity to recover from this really, if you're an aquatic organism and your stream dries, that's a pretty dramatic disturbance to survive. And so that just engaged me right away.
So that's a mouthful, though. What exactly are you looking at? What are macroinvertebrates?
Macroinvertebrates is just a way to say that those are the insects and invertebrates, snails and dragonflies and damselflies that live at least a part of their lives in the water. So dragonflies and damselflies, when they're larvae, before they're flying around, they spend most of the time that they're alive as critters underwater. And so that's true for a bunch of lots of flies. Black flies also spend most of their lives underwater. And so that is a particularly great way for us to look at how environments are changing.
How so?
They have different levels of sensitivity to change in the environment. We often call them indicator species, because we can go to a stream or to a habitat and find one of these organisms and say, oh, I know that must be really good water quality. Or I know that stream never dries, because if it dried, then there wouldn't be that insect there. And so we can use those sort of as tools to understand the broader ecosystem.
And our ancestors that lived in those areas, I'm from the northern part of Mexico too, and the Arizona area too. I mean, even without that kind of research, it was indicators for them back in the day, right? Of the land that they lived in and what to expect in terms of crops and water and things like that.
Oh, totally. And rock pools and the migration routes. Yeah, it was all based on these. They were following the animals and using those as a sign of what's happening with the ecosystem.
So what have you learned through your research that has kind of surprised you or didn't think about before you embarked on this research?
Well, one of the cool things that my students are doing in the laboratory here at USD is they're taking some of those individual species, like one species of damselfly or one species of aquatic beetle, and they'll look at them in the laboratory and try and figure out exactly what they're doing to be able to survive in this habitat. So there's sort of two parts of my research program. One, we go out to the desert, we have big nets, we put waders on, we sample aquatic insects. And then the other part is in the laboratory figuring out, well, how exactly do they do that? Where do they go? What's allowing them to survive when their stream dries? Fish can't do that. How can these aquatic insects do that? And so we have now 2 student publications that are based on this research. And so we're looking at these behaviors that they do. Sometimes the beetles specifically can fly away when the stream dries.
And where do they go? To another stream or?
To another. They can search out. They can fly for kilometers sometimes, miles and miles, to find the next aquatic habitat. But
then they come
water.
back to this one?
Mm-hmm.
So they have this incredible memory and sense of location.
Yeah. They have migratory routes just like birds do, some of the species. And then we also looked at how some of them can bury in wet sediment and just hang out down there. Some of them bury meters and meters below the surface, like they go way down there, down to where there is water. Some of them, there's a stonefly that can stay down there for up to 10 years in between rains. It's just amazing.
Wow. That's incredible.
Yeah, you don't think about that.
Right. And these are the places when you're driving on the highway and there's like a ditch.
Right.
And there's a little sign that says, somebody wash. And I always wondered, why would they name that ditch? Well, it's not always a ditch. In the rainy season, there's water there, and there is so much life that just pops out of nowhere and supports a whole ecosystem, birds and bats and the coyotes and mountain lions. It's all supported by this food web base.
So a lot of us don't often think about these things, right? When we're driving through the washes and whatnot. Can you give us an idea of why everything is in fact so interconnected, right? And why everything matters?
Well, I mean, this is why I think it's so important for folks to get outside, right? Because we can see, we're interconnected too. We're not separate from nature. And I think it's that perspective that sometimes gets us in trouble as humans, thinking that we're separate from nature. But all of those interconnections through the food web is a pretty nice example, right? You have the insects that start mosquitoes. Those start out their lives aquatic. And so the mosquitoes emerge from the water as adults, and they are the main food source of bats. We should all be really grateful for bats. That is like almost all they eat are these emerging mosquitoes. And fish eat the insects in places where there's fish and other organisms in the environment. And so it just propagates up, right? So that you need to have a solid base of the food web in order to feed all the levels above it. And so if you lose one of those, if there's a population crash, or if there isn't rain for 11 years, and that particular really great, awesome, well-adapted species can't make it, well, then you have a whole food web that collapses because the bottom of the food web can't survive.
And I'm curious, through your research, what kind of impacts are you seeing when you're studying these streams and rivers that dry up? Is it due to, the drought? Is it due to climate? What are you seeing?
Yes.
All
of the above.
All of the above. So, the main effects, climate change, of course, which in California is a combination of not just it getting hot, not just less rain, but it's the increased heat. So there's less water in the air than there used to be, right? And not just less water in the ground. Also, urbanization. Las Vegas, Phoenix, San Diego, LA, right? The first question I always ask students in my classes is, when you turn on your faucet, where does that water come from? And I have them make a little pie chart of where they think the water comes from. Would
And
you
what
like?
answers
Would
do
you
you
like?
get?
I was going to ask.
I was going to say,
would
what
you
do you
like
get?
to play along?
What are some of your most surprising answers?
What would you think?
I would say Colorado River.
Good. So that wasn't always true. That's true. We used to get most of our water from the San Joaquin River Delta, like the San Joaquin River up in the Bay Area. But now with the new agreements, we do get most of our water, probably 75% from the Colorado River.
And what are some of your surprising answers?
Well, most people think it comes from rainfall and reservoirs. We do have a lot of students who guess the Colorado River. We are in a desert. But also there's a new desalination plant in Carlsbad that's now giving us about 10% of our water. So that's when they take ocean water and they take the salt out and they make it into fresh water, which sounds like it would solve all of our problems. Unfortunately, it's really energy intensive, very, very energy intensive. So you have to, so there are other trade-offs with desalinization.
Right.
And then we do still get a little of our water. We get a little from our reservoirs. Those are the lakes like Lake Cuyamaca and other ones like Morena. And then we do still get some from the Sierra Nevada that's coming down through the San Joaquin River and the California Aqueduct.
But that's decreasing year after year.
Yeah, all those Central Valley farmers, but that's the same water that they need and that we used to use, which is why we switched to the Colorado River.
I'm interested to know what your thoughts are. I mean, we are recording this as we are experiencing massive, incredible, and tragic fires in the Los Angeles area. I'm interested to hear from you how you are looking at this unfold, given the research that you focus on.
Yeah, it's really devastating. I think we all have friends and family and communities who are really suffering right now. And my research is looking at just another impact of the same processes, right? This is just because it's getting warmer and drier. There's more tinder. It hasn't rained in a really long time, in combination with the processes like the Santa Ana winds that have happened for a long time. That's a natural thing that we deal with in Southern California. But when you combine that with these newer droughts and other human impacts, that's when we get these catastrophic crises like the LA wildfires right now. Yeah, it's very concerning.
Are there patterns in your research that are sort of predictors of when you know things are really bad and just, at a point where fires can start at any moment based on what, the insects and what you're looking at in your everyday research?
I mean, the natural communities in quotes, are responding in a similar way to human communities, right? They're responding to exactly the same things. Lack of precipitation, increasing heat, the amount of humidity in the air also affects the critters that I study in the streams. And so I can see by studying my streams and rivers in the desert and the times of year that they dry and the rate of drying, how fast they dry, and how the animals that live in them are responding to those changes. I can look at all of those as sort of parallel signs of, oh, yeah, here are some of the other impacts that we're going to see in our cities, in our urban areas as humans.
And I could also imagine that, in some of those streams and, areas that you study, are burned in some places, right? And what impact does that have additionally to just the drought itself and the insects that lived in that area? Or
well, it's so interesting because fire has been a natural part of California ecosystems for hundreds of years. And the indigenous communities that still live here are excellent fire practitioners. And when the colonizers came, they saw the effects of years and years of fire management. Those were actively managed. And so then when European colonizers came, they basically stopped all of that land management that was happening. And instead, we developed this idea of wilderness as the goal without people. And it turns out that people aren't separate from their ecosystems. Those people who used to be everywhere here and are now confined to smaller regions, they were doing active fire management on the land. And so when Europeans came in and stopped that activity, that began this buildup of tinder, of dead trees, of potential for future fires. And so the fires that we see right now are so catastrophic because we have been suppressing natural fires for up to 100 years now, sometimes in some areas, multiple 100 years since the Spanish got here. And so it's just if we could go back in time and learn from our indigenous teachers here, the Kumeyaay they have all this knowledge about land management that would be so useful and could really help us prevent these. But we're in a situation now where all that fuel's built up so that if there is climate change and Santa Ana winds, then we have these really scary fires like we're seeing in Los Angeles right now.
Several times in our conversation just now, you have mentioned the interconnectedness, right, between nature and humans and insects and all that live on this earth. If you can leave our audience with some knowledge, some little bit of information or a nugget of something, what would that be?
Get outside, get to know your community, both your natural environmental community and the people around you. This is all about connections. And we as humans are interconnected with all non-human life. I think that one of the best ways to see that is to get outside, which is one of the reasons I teach, is so that I can get students outside, falling in love with their natural habitats and seeing their role. But that can also look like working at a food bank. That can also look like connecting with other families in your area, right? Interconnectedness, I don't think is limited to recycling and working in streams and doing what I do. I think that we can all pursue interconnectedness to some level, and it's that collaboration and respect for human and non-human worlds that's going to help us get through climate change and these environmental disturbances like we're seeing.
Well, Kate, thank you so much for joining us today on this podcast. And if you like this episode, be sure to subscribe to catch our next one.
Thank you so much for having me.